Such a start is fully comparable with the direct starting of electric motors. You soon realize how much wear and how much power loss are involved. Gears, belts and chains are exposed to great stresses in the case of all direct starts. A burnout belongs on the drag racing track. In modern industry, it's a matter of soft starting instead. In certain cases, we try to solve these mechanical problems by installing hydraulic clutches and other expensive solutions like frequency drives. But there's a better solution, which at the same time eliminates the problem of high starting currents. ABB's Soft Starter program. Let's start by having a look at the starting current. This is what it looks like in the case of direct starts. As you can see, it's very high at the actual start. When starting with a loaded star-delta connected motor under load, the instrument shows this starting pattern. So star-delta starting is not particularly good here. The starting current essentially has such a pattern. In the star position, the motor torque is not sufficient for acceleration up to a sufficiently high speed. When switching over to the delta position, you get this current peak. In difficult cases, the current is even higher in the case of a direct starting. At the same time, you also get a torque shock. Consequently, star-delta starting can be unsuitable for feeding networks and transmission systems. However, if an ABB soft starter is incorporated in the motor drive, the pattern looks like this. No sudden current and torque surges, regardless of whether the motor is under load up on starting. This smooth start curve results instead. So the current path that we just saw gives a soft and jerk-free start. The speed increases continuously and steplessly up to full speed. Listen, that's what it should sound like. How do we achieve this? The soft starter is fitted with thyristors in the main circuit, and the firing angle of the thyristors is controlled by a microprocessor. Initially, the voltage supplied is 0, but it rises relatively quickly to a value where the motor starts softly. The voltage then rises continuously to full rated input voltage, and at the same time, the motor accelerates softly to its full speed. The ramp time can be set at a selection of values between half a second and 30 seconds. When up to main voltage and full speed, the motor then operates normally. Soft starting is based on the principle of starting with reduced voltage. The ramp time is adjustable and possible to set to meet any requirements. The longer the acceleration time, the softer the starting pattern, and the lower the starting current. In the pumping station at Norrköping Waterworks in Sweden, they had problems with too high a starting current when switching from star to delta connection, because the engine was loaded when starting. Then, after installation of an ABB soft starter, the current dropped from 350 to 80 amperes. And an ABB soft starter was also selected for this timber conveyor at a sawmill in Mörlunda, Sweden, in order to reduce the stresses when starting. There are many other types of motor drives where ABB soft starters are the obvious solution from the economical point of view. ABB soft starter should be used as a matter of course in, for example, hydraulic lifts, conveyor belts, fans, and pumps. The soft starter is also equipped with a soft stop function. The engine then stops more slowly than in the case of direct disconnection of the network. The voltage is driven down along an adjustable ramp. Since an asynchronous engine compensates lower voltage with higher current, the motor speed is only reduced during the latter part of this voltage reduction. Soft stopping is therefore of great interest for high-load operations with small rotating masses, where an immediate disconnection of the motor from the network causes problems, for example in the case of certain conveyor belts and pumps. By connecting to an external current transformer, you activate a current limiting function which you set in that blue field. Here you set the maximum current, and this set current value can then not be exceeded during the starting sequence. This also means that the starting torque can be varied along with the current limit setting. When the current has increased to the set limit value, the voltage ramp is interrupted and the voltage remains constant until the current has dropped below the set current limit. The voltage ramp then rises up to the rated main voltage. PSS 1830 and bigger can also be wired into the motor's delta. The current is then lower compared to a connection in line with the motor. As the current is lower, you can therefore select a smaller soft starter device for the same motor. This is how it could look. A soft starter is not just a means whereby you can start up gently instead of making a tearaway start. It's more than that. ABB's soft starter means reduced wear on transmission parts, fewer service interruptions, lower service costs and power consumption. It'll greatly help guarantee the availability of your machinery and your equipment. An ABB soft starter is an investment with fast payback.